Hi everyone. In today's lesson, we're going to be continuing what we started last lesson and keep investigating how to tweak the appearance of a parabola. In the previous lesson, we saw how throwing a coefficient in front of the x squared, what we call the value of a, caused the parabola to be stretched, taller or skinnier, or fatter, and also causes the parabola to either open upwards like a happy face or open downwards like a sad face. Today we're going to look at this possible transformation. What happens if you add or sometimes subtract a number to the x squared? Now, to get a feel for how this kind of tweak will affect the appearance of the parabola, we're going to again build a table of values, and from the table of values we're going to draw a few parabolas so that you can physically see the impact on the parabola's appearance. So let's prepare a table of values that looks like the following. Go ahead, pause the video and set up the following table. Alright, now we're going to draw three parabolas. Let's start with the first one. As usual, we're going to always start with the basic one, which is y equals x squared. And we're going to use our usual x values, minus 2, minus 1, 0, 1, and 2. And the usual suspects are y would equal 4, 1, 0, 1, and 4. So these are the coordinates of our good old normal basic parabola. Now, let's tweak this parabola. Let's try the following. Y equals x squared, and let's tweak it by, how about adding 3. Let's see how this changes all the y values. So, when x is minus 2, let's plug that in. Minus 2 squared is 4, and 4 plus 3 is 7. Okay, let's keep going. When x is minus 1, minus 1 squared is 1, and 1 plus 3 is 4. Let's keep going. When x is 0, 0 squared is 0, and 0 plus 3 gives 3. Next, when x is 1, y will equal to 4. And the last one, when x is 2, 2 squared is 4, and 4 plus 3 is 7. Interesting. If you look at it carefully, you'll notice that all the y values from our basic parabola were increased by plus 3. Now, let's do one more. Let's try this one. Y equals x squared, but this time, let's take away 2 from that. Alright, let's try it. When x is minus 2, so minus 2 squared is 4, and 4 minus 2 is 2. When x is minus 1, minus 1 squared is 1, and 1 minus 2 is minus 1. Next, when x is 0, y will equal to minus 2. Next, when x is 1, y will equal to minus 1 again. And the last one, when x is 2, y will again equal to 2. Interesting. Compared to the basic parabola, it looks like all the y values lost 2 units. They all decreased by 2. Now let's prepare a grid to draw all 3 of these parabolas. You're going to need a grid that's at least this tall. Alright, once you've prepared the grid, let's draw each of these three parabolas. Like usual, let's start with the basic one first. I'm going to draw that one in black. So if you draw it carefully, the basic one should produce a parabola that looks about like this. Yeah, that's not half bad. Alright, now let's take a look at what the next parabola looks like. The one where I added 3 to x squared. I'm going to draw that one in green. So carefully put down all your coordinates. The coordinates are when x is 0, y is 3, right about there. When x is minus 1 and positive 1, both the y values are 4. So that'll be about there. About there. Alright. And when x is minus 2 or positive 2, the y value is both 7. So that would put it about there. And I would put this about there. And draw your parabola. Let's label that as y equals x squared plus 3. Okay, now you can clearly see that that parabola actually moved up on the Cartesian plane by 3 units. Now let's take a look at the third parabola where 2 units were removed from the x squared. I'm going to draw that with a red pen. Okay, so carefully put down your coordinates. When x is 0, y is minus 2, right there. When x is minus 1 and positive 1, both the values, y values, are minus 1. So that'll make it about there and there. And when x values are minus 2 and 2, both y values were positive 2. So I guess that would put it about here and here. So let's complete this parabola. Interesting. Let's label that one as y equals x squared minus 2. Now that we drew it, you can clearly see that by taking away 2 units from the x squared, it caused the parabola to shift down the Cartesian plane by 2 units. Very interesting. Now let's put down our observations. Now if you look very carefully at the graph, I wonder how many of you noticed perhaps one of the most important observations about what the value of c reveals. Do you see it? If not, slap yourself and realize that c reveals the initial value of the parabola. Take a look. When c was positive 3, the green parabola passed through y equals 3. When the value of c was negative 2, take a look. The red parabola cuts the y-axis at negative 2. So the value of c reveals the initial value of the parabola. Very important observation. And of course, the more obvious observation was that as the value of c increases, that will cause your parabola to shift up. And if it decreases, it will cause your parabola to drop down. And that completes our analysis of how the parabola changes if you were to add or subtract a number or value from x squared. It will cause the parabola to either move up or down, and it will also reveal to you the parabola's initial value. In the next lesson, we will still continue this section with one more tweak, and then we're going to put everything together.